Yes, Francis. Good morning.
It's afternoon this side. Good afternoon.
Okay, afternoon. Oh, okay, fine. Good afternoon. What is the time in your country now?
It's 39, 40 past 12.
It is?
40 minutes past midday.
Okay. Okay, so we just start in 2, 3 minutes. Okay.
Good afternoon, Madam Dimple.
Yes, Martin, good afternoon.
Well, I'm very sorry. I've been off because when I traveled, I felt sick. I've been off for a while up now. So
Mm-hmm.
I didn't
But
attend
this is our last
yesterday.
class
Couldn't
theory.
sit fever
Theory.
yesterday. Sorry.
Yeah, for theory, this is our last class. For practical, it will continue. Okay.
Mm,
But for theory,
okay.
this is our last class. Okay, so let's
Okay.
start.
Mm,
I just share
okay.
my file. Right, just a second.
Okay. Thank you.
You're welcome, Martin.
Yes. Thank you. Why, Francis?
Fine, thank you. Hope you get well soon.
I will. I will. I will. Thank you. Thank you.
So yesterday we did, what do you say, networking concepts.
Yes.
Yes,
No.
you were not there, but Francis, I think you were there, right?
Mm, mm.
We did networking concepts, and
Yes.
today I'll start with internet concepts. We'll start with internet working concepts.
Okay.
Okay,
Yeah.
and yes, and we did operating system also yesterday, right, Francis? Yesterday we did operating system concepts.
Yes, we did the operating system yesterday.
Yeah, types and functions, right? And networking concepts. So today we'll start with internet
Yeah.
working concepts. Okay. So I just share my file. So yes, what is internet? What is internet?
Uh, According to my understanding, hello.
So yes, yes,
Yeah, according to my understanding, internet is where two or more computers are connected.
hmm. Okay, so that can be networking also if I connect to computer within my office, right? But that can be a LAN, that we can call it a LAN, right, Francis? We did it, right? So that can be a LAN also when I connect the computers within some office or building, right? Or using some cables,
Yes.
right? But the
Yes.
internet is the biggest network in the world, you can say. Okay, so where you can connect any computer from one part of the world to the any computer to
Another.
any another part of the world, right? So
Okay.
this is internet, and this you can say the biggest network, and we can say this is the example of WAN also, right? We did LAN, MAN, WAN, so this is the example of wide area network, WAN, right? But now the
Yes.
yeah, you must have heard about IP address. Have you heard about IP address?
Yes.
Yes. What is IP address? Yes. What is IP address?
Madam, you said IP?
Yes. Sorry.
You said IP?
IP. Yes.
IP is it addresses. It has to address, right?
Yes, right, right.
Yeah.
So in
Thank you.
internet, when I have to send some file or some data or some information from one computer to another computer, and there are so many computers, kind of you can say unlimited number of computers in today's time, which are connected in internet all over the world, right? So now how I will identify, like from if I have to send some file from my computer to your computer, so how it will identify that to which computer I have to send, because there are no trillions or maybe more than computer connected to the internet right now all over the world. So this is kind of like we send a letter from the sender to the receiver. We put an address, right? So the same way in internet also, all the devices connected to the internet is not only laptop or computer. Whether you have no your mobile is connected on the internet or any other device nowadays. Most of the devices can be connected to internet, right? So that is called IoT also, internet on things. So your car can be connected to internet, right? Any machine can be, your TV, fine, your no. So all these kind of devices can be connected to internet, so each devices will have a separate unique address. Just a second. Yes, so like we used to send a letter. Hello, hello. We send a letter, and we if I have to send a letter, I will put the address of the receiver on it, right? So the same way, when I have to send a file digitally on the internet, so obviously, what I was saying, that every device connected to the internet has a unique address, okay, and that is called IP address. Okay, internet protocol. IP means internet protocol address. So that, using that address, your data travels on the internet. Okay, so every network has a ID, and every device in that network has a ID, or you can say address, which is called IP address of that device. Okay, so earlier it was IP4. Nowadays we are shifting from IPv4 to IPv6. IPv4 is the version 4, and IPv6 is the version 6. So mainly IPv4, I mean, was used to give the IP addresses to all the users all over the world. But when after the internet, when it started, they didn't have the idea that it will grow at such a, huge size. So that is why nowadays the addresses IPv4 distributes, they are less than the number of the users. Okay, so to increase the range of IP addresses, we have switched from IPv4 to IPv6, that can allocate more unique addresses to each and every device connected to the internet. Is it clear what is this IP address? And
Yeah.
right,
Yeah.
right.
Yes.
So,
Yes.
this is the networks of network, you can say all the networks are connected through one network, that is internetworking and largest network, and it uses IP protocol and basically IP address, and which comes under the TCP IP protocol. TCP IP is transmission control protocol, and IP is internet protocol. Now, what do you mean by protocol? Protocol means set of rules. Okay, so there, all the organizations all over the world, they have set up some standard rules. Obviously, like if I have some other rules in my country, okay, to send or receive the digital data, and every country, suppose they are following some other, their own set of standards, so then it will become very difficult to communicate among the countries. Okay, so that is why they have set standard protocols. Protocols means rules that all countries will follow when they will send or receive the data from the internet. So that is called TCP IP protocol. Okay, this I have explained.
Okay.
Now, this third point is what we use in this internet. We use www. What is the full form of www? What is that?
It is World Wide Web
Yeah, this is
website.
what, yeah, whenever we type some website name, so this is World Wide Web. Then the email services we use, then we use audio and video conferencing like we are using right now. Okay, and this internet is based on client server model. That also I discussed yesterday. What is client server model, Francis? Do you remember?
Sorry,
What is client server model?
I don't remember very well.
Client server model, I told you that, suppose if I'm accessing Gmail, so Gmail has a server, or any bank you are accessing, so it has a server. Server means where all the data they store. Okay, which has all the power, security, right? So whenever, suppose I type something google.com, and I open any website, suppose any bank or igno website, suppose, right? So that igno has one server where all the information is stored. Okay, so when I type igno.ac.in, and when I click on a link, suppose I click on assignment link, so that means my browser is requesting the igno server to send that page, because all the pages are stored in that server. What are pages now? Like any website is a collection of web pages basically. Okay, So collection of web pages. So you click on one link and it shows you that page. Then you click on another link, then it shows you that page. Okay, so any website is a collection of web pages, and all these web pages are connected through some links, right? So whenever I click on link, so that means I am requesting that particular page, and where all these pages are stored in the server, right? So then the server will send back that information or that page to me, right? So that means my browser has become the client, okay, and then that is the server. Huh.
and the prosecution. Hello, Abdullahi, how are you? Yeah, fair. Mm, fair. Francis O. Abdullahi, could anyone assist me with the yesterday's notes? Not even yesterday notes. Saturday, it's Friday, Saturday notes. Would anyone have done a share with me on my email?
I'm so sorry, guys. So sorry it took so long. It's something urgent. Yes. So what I was saying, we were discussing about internet, www, email, video conferencing, and yes, I was explaining client server model. So I was saying that every website like has a, what do you say, server where all their information is stored, right? And when we click on any page on any website, that means we are requesting some information, so we become the client, and that this computer which provides the information, that becomes the server. Okay, so obviously there can be n number of clients to a server. Now next is, this is what I have explained just now, that any website has a collection of web pages, and those web pages are created in HTML language. Okay, so this is hypertext markup language. So that is why they are called HTML linked pages. What I just explained, that all the pages are linked with a hyperlink. When I click on a link, that is called a hyperlink. So this is how all the pages are connected. Okay, and our web browser become the client when we request, when we click on a page. Okay, and that information which is somewhere stored on any web server anywhere, right? Is this clear? This concept is clear, what I just now explained? Okay. Yes, you
Yeah.
want to ask something, Francis? Any doubt you have?
Yeah, I
Okay,
was
so
just
now,
asking if we shall, if it's
sorry.
possible, you. I was just wondering if you will take us back to the numbering system. I didn't get that topic very well.
Okay, I'll, if you have some doubt, I'll take this topic. Okay, first let me finish this and I'll come back to that topic, right? In the last 15 minutes. Okay,
Okay,
so
Okay.
please.
this is now again, this networks can be divided in three kind of network. One is internet, one is intranet, and one is extranet. Okay, so internet is, which is global, right? All the computers all over the world are connected to each other. That is internet. What is intranet? Intranet is local, what we say as a LAN. Okay, so where basically in internet everyone has permission, anyone can access your website, anyone can access the information, right? So this is your server, or you can say your website is open in the public. That is internet. And in intranet, that is like you have given permission to only to employees of your organization. Okay, and maybe your suppliers, no, not only, we say just your organization employees. So suppose if you have any server and you have given password to only your organization's employees. Okay, so that is intranet, only your employees can access your company's server, right? That is intranet. And in internet anyone can access, right? And what is extranet? Extranet is between them, internet and intranet. Okay, so internet is public, anyone can access. Intranet is private, only the employees of your company can access your server. And extranet is not to close and not to open. This is in between, like you have not given permission to everyone in the public. Okay, and it's neither you have given permission to everyone, and nor you have given just to your employees. Okay, so this is outside your organization, you have given permission to your suppliers, or maybe some other related companies which provide you some information or some raw material or anything like that. So this is extranet, which is between internet and intranet. Okay, so this is not only related to your company, and neither it is, no, nor it is open for everyone, but yes, in between you have given permission to, other than your employees, you have given permission to outside your company also, to some of your, no, limited connections. Am I clear? internet, intranet, and extranet. These three things are clear.
Yes, please.
Yeah, so intranet is the local one. So obviously this is time saving and cost effective. You can share information with all your colleagues, and communication is very easy, cheap, right? And collaboration, like all the employees can collaborate with each other. They can share and distribute information with each other. That is intranet advantages. Internet, we all know. Okay, so if I say igno.ac.in, so first of all, this is this is all your website name. But now what happens, like as I said, IP address, right? So IP address is something like this. Okay, three digits, then dot, then some digits, then dot. So this is divided in four parts which are separated by dots. Okay, and then some numbers is given. Okay, now what I am saying, like if I type www.igno.ac.in, that means it will open that server. Okay, how it will search for that server? By its IP address. Okay, how? By its IP address. Now I can't remember its IP address. I can't remember the IP address of google.com. I can't remember the IP address of igno or any shopping sites, right? I can't remember because they are something, digits like this one. Okay, unique set of number, right? And so I can't remember their IP addresses. So what is the solution? The solution is they are given some name.
Excuse me, madam.
Okay. Yes.
Excuse me,
Yes.
madam.
Yes,
Now,
yes, Martin.
under extranet is where we find Wi-Fi
Yes, yes, yes.
and the other.
This is all
No, me,
this is
I
all
would,
related to
like to give
Wi-Fi only.
example.
Sorry.
Hmm?
What?
As in extranet examples, we have Wi-Fi
Huh?
and what other
Yes, we
one?
have Wi-Fi.
Hmm.
I'm saying in all these three things you have Wi-Fi: intranet, internet, and extranet. This is that in intranet you have given permission to only your employees so that they can access your server. In internet,
Yes.
like I'm typing igno.ac.in, so this is something, the name of its server. This igno.ac.in is the name of the server. Okay, anyone can
Okay.
access that server. Okay, this is internet,
Okay.
this is in public domain. But extranet is not limited to your employees and not open for everyone. This is somewhere in between. Okay, outside your organization also some people can access, like you can give an access to your students, to your faculties, to your staff. Okay, not only, but this is not open to all. So in that case it will become extranet, because some institute has given permission only to its students, to its staff, and to its faculties to access their server. So in that case it will become extranet. But Wi-Fi is there in everything. It's only how many people can access. If it is open for everyone, this is internet. If it is only limited to your organization, this is intranet. And if you have given permission to outside your organization, but not everyone, to few people outside your organization, then it is extranet. Clear, Martin?
Yeah, it's now clear. I've got you now. Thank you.
Okay. So what I was saying, that as I said, every computer on the internet has some IP address, but we as a user cannot remember their IP address. Okay, like if I have to type some igno.ac.in, I cannot remember its IP address. So what is the solution? We give it a name. Okay, I can remember igno.ac.in easily, right? So now, but in internet it will travel through IP addresses only. Okay, but as a user I can remember the name, I cannot remember the IP address. So what is the solution? The solution is, in between there is domain name server. What is this domain name server? When I type name of the website, it will convert it into its IP address, and then it will search for that IP address in the internet. Okay, so domain name server is which gives a name to its IP address. So that, are you getting my point? That IP address will be converted to a name. We can access by name, but internally that will be accessed by IP address. It will identify that server IGNU server using IP address only, or any other website you take. Okay, it will identify using that IP address only. But for us, for the user, we cannot remember the IP address. So this there is one server in between that is called domain name server, and its job is to convert that IP address into a name. Getting it?
Yes,
Yes.
please. Yes.
Okay, suppose if you have an organization and where you know each other by name only. Okay, you don't know his address, his ID number, right? So you will search each other by name only. But in a system, for that name you have stored his address, you have stored his ID number, right? So somewhere they have stored every information against that name. The same way DNS is storing its IP address against its name. We will search by name, and internally it will be converted into that IP address, and then it will search the internet using that IP address only, right? Then this is the history of internet. So this was like ARPANET, a military organization in the US, which originated in 1969. Defense Department of US in 1969 originated this concept of internet, which was called ARPANET that time. Okay, and they devised this www browser, DNS, TCP/IP protocol, everything, right? Then this is okay. Now, as I said, when this was devised, TCP/IP and OSI model. So there are two types of models in internet. Okay, so like when this idea of internet was devised that time, the first model which was developed by ISO, International Organization and Standardization, they developed a model called OSI model, right? Because as I said, because so many countries are involved in internet and they cannot use their own standards, so there has to be some common standards. Okay, and for that they devised some no common reference model, because in every country their technology is different, their architecture is different, their devices are different, right? So this is called heterogeneous architecture. Same architecture means that is called homogeneous. When they are using different architecture, that is called heterogeneous architecture, right? So to communicate with each other, they wanted some standard model. Okay, regardless their, without regard to their, what do you say, architecture, right? So that was the first model that was devised, that is OSI model. So in OSI model, there were 7 layers. Okay, and this is the 7 layers. So how it is showing that how data travels from one sender to the receiver. From first layer, that is the physical layer, the data will be no from layer 1, 2, 3, 4, 5, 6. So from the sender it goes upward, and then it is sent to the another network, from sender to the receiver to the layer 5, and then it will go to that lower layer, layer 1, which is 0 1. 0 1 is the physical layer. Ultimately that every data is in the form of 0 1. So data starts from 0 1, then it changes its form and it goes to the top layer on the sender side. So it goes from bottom to top, and from the on the receiver side it goes from top to bottom, because bottom layer is the 0 1 layer. Okay, so this is just the purposes of internet. We use it for no email, website, messaging, social media. This is just resource sharing, audio, video. So now I'm talking about these layers. Okay, and in every layer between there is some interface, and every layer has some particular job. Okay, it provides a particular job to its lowest layer, right? So now we'll see what are the layers. So it consists of, OSI model consists of 7 layers. These are the 7 layers. Physical data link layer, as I said, from the sender it will come down, application layer to presentation, session, transport, network, data link, physical, and from the receiver side it will go from bottom to top. Okay, this is how it will go from the sender side, from application to physical, physical layer means physical stream of data in the form of 0 and 1. And on the receiver side, from the physical layer to its top layer, application layer, right? Now we'll understand what are these layers. Application layer means, as I said, when you open some application on your computer through which you are accessing the internet, whether it is some website, like I have opened Zoom, this is Google Meet, these all are the applications through which I am accessing the internet. That is the application layer. Which application program you are using? You are using email, you are using Gmail, right? So these are the applications. Now second layer is the presentation layer. Presentation layer after application layer, second is the presentation. Now presentation layer is, like, suppose what I do, sometimes I have to send the data uh, in Gmail or whatever. So sometimes I encrypt my data, sometimes I compress my data. Okay, so that means uh, when we transfer the data from one application to another application, we change its form. Okay, we change its form. So that is, we sometimes we compress the data, sometimes we encrypt the data for its security. Okay, so that is called the presentation layer. Third is the session layer. Session layer is when I start communicating from one sender to another receiver. What happens in between? I start a session, right? I start a session. So session layer means that will create, manage, or terminate the dialogues between the users. Okay, when two systems start communicating, so how that session will start, how that session will end, so that is the job of session layer. Okay, so this layer handles the connection, this layer handles the format of your data, this layer is just the application through which you are accessing your network. The next is the transport layer. Now what is transport layer? That whatever message you are sending, that will be broken into some messages, that file will not be sent as it is. Okay, that file will be broken in some messages. Okay, so this is basically what it means. Like, if I'm sending a file, that's not that the entire file will go on one route. Okay, that file will be broken down into many messages, and it will be sent through different channels, different mediums, different route it may take. So when my file will reach your computer, it may be divided into many parts on the way, and maybe all those parts will be sent to you from different routes. That's also possible. Now on your computer, the transport layer will assemble all those parts and make it the original file. So this is the job of transport layer, that how the message will be divided into parts and sent from different paths, whichever path is available. Okay, all the data will be sent from maybe sent from different paths, so that it reaches fast. And then on the receiver side, all these parts, or you can say packets or messages, are assembled. Okay, and how they are assembled? Because when we are sending the data, we divide the data in different messages and we give them some numbering, sequence numbering. Okay, so my file will be divided in four parts, and it will be given 1 2 3 4 numbers. And when it will reach your computer from different parts, maybe the first message is coming from one route, maybe fourth message is the part 4 is reaching first, then after that you receive part 2. No, maybe they are arriving in different order also. So it will be the job of transport layer to again assemble the entire message, and then put it in a proper sequence. Okay, put it in a proper sequence. Then what is the role of network layer? Then after this, you see presentation, session, transport, this is divided in different parts. Then what is the role of this network layer here? Network layer is which takes the responsibility of sending data from the sender computer to the receiver computer. This is responsible for routing the data from end to end, like which data packet will take which route, that which is the shortest route, that will be decided by the network layer. Okay, so it will see that how to avoid the traffic. Okay, which route should be taken. So that route is decided by this network layer. Next is your data link layer. Data link layer is your, no, this is the next layer after this physical layer. Physical layer is your data is ultimately in the form of 0 and 1 only, right? So in data link layer, this data, uh, with this data you add the address of the sender and the receiver, and that is called a frame. Okay, so with this data, when you attach the address of the sender and receiver, this is called a frame here. Then it data comes to network layer. This is called a packet. And in transport layer, it transfers the data in the form of messages. Okay, so here what happens in data link layer? Data link layer is it creates a frame. As I said, this is called frame. Okay, so this is responsibility of error-free transport of data between the systems, right? So this is data link layer. And last is your physical layer, where it sees that which medium, which wires will be used, which no like we did yesterday, different types of wires, routers, switches. So which physically, which communication medium will we use, which type of signals will be used, connectors, voltage. So that physical implementation comes here in physical layer, right? So here I have shown this chart. Physical layer is the physical medium. Data link layer means the frames, error-free transfer of frames. Network layer, it is called packet from source to destination. So it takes the responsibility that no error should be there in the actual data, right? Whatever data I am sending you, you should receive the actual data only. No data should be missed, skipped, okay, or duplicated, right? So that is just to check all these things is the responsibility of data link layer. Network layer decides the best route. Transport layer assembles it, the entire message in a proper sequence. Session layer starts and establish and terminate the session. Presentation is compression or encryption, right? And then application is where the user can see the data, right? So this is the physical layer, which is the just the stream of 0 and 1, and from physical layer it will be sent to the data link layer, right? So as I said, physical layer will just see the transmission of data, which topology you are using, which signals you are using, that all we discussed yesterday, right? In data link layer, this is your physical data, and here what it will be added before and after that, it some address will be added and it will become a frame. Okay, after adding the address, so it takes the responsibility of error free transfer. Here in before and after your packet, some header and trailer will be added. Okay, this header and trailer means the destination address will be added. Okay, so this data link layer is it will add the physical address to your packet, your data, and it will be called a frame, and then this frame will be transported. Okay, so then next is the network layer. Network layer, this becomes a packet, and it will select the best route for your packet, right? Above network layer, we have transport layer. In transport layer, as I said, it's different packets will be received from different paths. So transport layer job is to assemble all the parts in a proper sequence. Okay, and as I have written, segmentation and reassembly. And session layer, above transport layer, we have this session layer. Job of session layer is to dialogue control. Okay, start a dialogue, manage the dialogue, terminate the dialogue, right?
Yeah.
So this is the 7 layer of OSI model. So presentation layer, how to format your data, like for application to application, which application the user is accessing according to that application, your data will be formatted, you can say, right? So here you do the compression, decompression, or you can encrypt, or you can encode. Okay, so that is all is done in presentation layer. So it's acts as a data translator. Okay, so that converts from one presentation format to another. Suppose I am sending from one application and you are receiving in some other application. So data from my application format will be converted into your application format. That is the job of presentation. Okay. Top is application. Yes. So this is presentation layer. Translation is done. Encryption can be done. Compression can be done. Okay. Encryption is done for the security. Top layer is application. Application is, as I said, which application user is using, sender and the receiver. That is your application layer, right? So if you are using mail services or you are using, no, there are different databases like whichever website you are using. So all that come into this application layer. Now this OSI model has 7 layer and it was devised when internet started, but this is only theoretical. Practically, which model is used? TCP/IP model is used. It has, in some books you will see it has 4 layers, and in some books you will see it has 5 layers. But basically, this TCP/IP model is used. OSI model is not used practically, right? So this here how these 7 layers of OSI model are converted into 4 layers of TCP/IP model. The physical layer and data link layer is combined into one network interface layer. Network layer remains the network layer here. Transport layer remains the transport layer, and all these 3 layers, session, presentation, and application, are combined in one layer that is called application. So these 7 layers jobs are done by these 4 layers in TCP/IP model, right? So this is the first is physical plus data link layer. Right now here I am telling you on which layer which protocols are used. Those protocols I told you, the rules, the syntax. Okay. So on this physical layer, these LAN, ARPANET, these models protocols are used. In network layer, IP protocol is used, internet protocol. Transport layer, these TCP and UDP comes, and in application it can be FTP, SMTP, simple mail transfer protocol. FTP is file transfer protocol, right? DNS, I just said, domain name server. What is domain name server? What is DNS?
The domain name server is another way of identifying the IP address.
Very good, very good. Right. So all these comes in the top application layer, right?
Yes.
Okay. So yes, so this is the layers and their protocols. Okay. So next, I'm explaining these 4 layers now. Network access layer, which is here, network access layer or network interface layer, you can call it. So here it is performing the job of these 2 layers, physical layer and data link layer. Okay. So it is a combination of physical layer and data link layer in the OSI model. So it will decide how the data should be sent physically. So this is, and what protocols come on this layer: token ring, Ethernet, frame relay. Okay, these are the names of the protocols. Next is the network layer, or we call it internet layer also. Okay, this network layer is called as internet layer also. So this network layer, what is the job of network layer? To decide a best route. Okay, so same job it is doing in this TCP IP model. Okay, so when you have to send the packet from one network to another network, okay, so all the packets, your data will be divided in different packets, and all the packets can take different routes also. Okay, so which packet will be transferred from which route, that is the job of internet layer, right? That routes decision will be done by the internet layer. Next is the transport layer, is same. Transport layer is assembling of the message in a sequence. Okay, this is the transport layer, which does the job of flow control, error control, segmentation. Desegmentation means assembling and all, right? So, and then after transport layer, we have the application layer, which we just said. You may be using some mail service, you may be using some website, right? So you are maybe some downloading some file, right? So these are the different protocols that we are using in application layer, right? So this is two models come, TCP IP and OSI model, and their layers. Okay, and what is IP address? As I just said, IPv4 and IPv6. So in IPv4, this is 32-bit number. Okay, and IPv6 is 128 bits, and IPv4 use 32-bit. Okay, so as I said, in 32-bit, less number of IP addresses could be generated. So that is why now we are switching to IPv6, because nowadays the need of unique IP addresses has increased. Okay, by such a huge number. So first I'm telling you the format of IPv4 where 32 bits are used. So this is 32 bits means 0 to 31. Okay, where 8 bits are used for network ID, right? And rest, how many are left? Rest 30, 24. Okay, from 0 to 7 is net ID, and 8 to 31 is your host ID. Host ID means one is the network ID of your company, and in that network ID of your company, which computer I have to send. Okay, that is called the host ID, is the ID of that computer. And net ID is the ID of that network in which that computer is linked. Okay, so this address in IPv4 is divided in 5 classes: class A, B, C, D, E, right? So in class A, this is 8 bits are for net ID, and 24 bits are for host ID. In class B, 16 bits, 0 to 15 for net ID and 16 to 31 for host ID. In class C, 0 to 23, I mean 24 bits are for net ID and only 8 bits are for host ID. Okay, this is multicast address, which is used for multicasting only, class D, and class E is reserved for future use. So basically, here when host ID is of very less bits, here if I say only 8 bits, so that means 2 raised to power 8 addresses or IP addresses could be generated. Here this is of, what do you say, 16 bits. So 2 raised to power 16 addresses could be generated for different computer IP addresses. So obviously this is very less, right? So that is why we switched over to IPv6, which uses 128 bits. So you can imagine 2 raised to power 128 addresses can be used. So here this class is range is divided from 0.1.00 to 126.0.0.0. Then in B, 127 is not used, 128.00.2 191.255 dot like that. Okay, here 192 to 223. Here 224 to 239. And here 242 to 47. That is how these classes and their range of addresses is defined. Class A will get its address between this range. This is the lowest range, this is the highest address. Okay, this is the range of IP addresses as their classes. So it uses 1, 2, 3, 3, 3, 3, 4, 3 the. So it uses 8 bit of the 32-bit addresses. Right? So this is 32-bit 4444. 4 bits, 4 bits, 4 bits, 4 bits. Right? So this is the class A. It can give 16 million addresses, which is nowadays is nothing. 16 million is nothing. The number of internet users are much more than this. Okay, so this is the how many addresses it can allocate, and 127 is reserved for loop back addresses only for the local host. Right. So here I have given the difference between IPv4 and IPv6. IPv4 uses 32 bits, IPv6 uses 128 bits. Okay, here it is 32-bit means 2 raised to power 32. This many addresses can be given, address spaces, and 128 bits it can allocate. This is the number of addresses it can generate, IP addresses. Okay, which is much larger than IPv4, and they uses hexadecimal representation. Okay, this is written something like this is the IPv4 address. This will be written in IPv6 like this. This will divided by dot. This is divided by colon. Okay, this is each part is of 4 bytes, 1 byte. Okay, only then. And here in IPv4, 1 byte is equal to 8 bits. So 1 byte, 2 bytes, 3 byte, 4 byte, 4 bytes. So 8 for the 32. That is how it becomes 32-bit. Okay, this is 8 bits it can use for one part. And here this is like IPv6. So this uses hexadecimal number. Okay, and what is the meaning of private IP address and public IP address? Public and private. Public IP addresses like the IP address which is in the public domain and they cannot be duplicated. Okay, but still, if I will give a unique IP address to each and every device, suppose if there may be 10 devices in one house only, okay, and so many, can you can count, you cannot count the number of users on the internet. So then it will become very difficult. So what we do, in one house, if one router is coming, one internet connection is used. So I will give one IP address to that internet connection, to that one router. And then inside that house, that is their private IP addresses. So in your house, the same IP address you can give to your mobile, and the same IP address I can give to my mobile in my house, right? Because that is your private IP address and that is my private address. That is not on the public domain, right? So that can be duplicated. But public is, which is the main IP address given to your one connection, that cannot be duplicated. Every internet connection will have a separate IP address, main IP address given to your home. Clear? So this is the story of internet IP addresses, how they are divided, their versions. There is one static and dynamic IP address also. Static means if one IP address is allocated to your router, your internet connection once, that will remain same whenever you connect to the internet. But that is expensive because for that they have to fix that IP address for you. Okay, but in case of dynamic IP addresses, like sometimes you are connecting, sometimes you are leaving, right? So that is dynamic. So every time whatever IP address you will get will be different. That is dynamic, right? And who allocates this uh, IP addresses? This is allocated by DHCP, dynamic host configuration protocol. Okay, so this DHCP assign the IP addresses. Okay, so mostly in homes we use dynamic allocation, right? And yes, nowadays I'm not going into detail. I'm just giving you one idea. Nowadays, we addressing we use is classless addressing. Like as I said earlier, this was IPv4, and where we have divided the addresses in these classes. But nowadays we use classless addressing. That is called CIDR. Okay. Right? So this was invented few years ago, right? So this is about internet. Can I close this file now? Yes, Abdullah, tell me. You missed the lecture in between. Yes, tell me. You have some query. Yes, yes, sure. You want the file for this theory lectures or those practical? No, theory lectures you are talking about, right? I have sent you till that number 5, right? Fine. So I just send you. You okay? I must be having your email ID, so I'll send it to you. Okay, I'll send rest of the lectures today itself, right? Not 2 lectures only. I must have sent many lectures up to number system. I have sent. And first, tell me, should I close this file? Sorry, I just closed this Zoom file. Okay, so I was checking the number of lectures I have sent. I have sent you 4 lectures. Lecture 1, lecture 2, 3, 4, and it's practical also. So 5 files I have sent you already, except yesterday's and today's lecture. Except yesterday's and today's, Monday and Tuesday. Till Friday, whatever we did, I have sent you all those files. So now I have to send you this 6, 7, what we did yesterday, networking, operating system, and internet. These three files I have to send you. So that I'll mail you today. Okay. First, you can come back to your doubts. Open your file. If you have any particular doubt in some question, you can show me that. Yes, yes, I'll surely send you. First, you want me to open the file, or you will open your file and ask me your doubts? Will you open your file, or should I open my file for your doubts? I'm asking. I mean, if you have some particular doubt, you can open your file and ask me that doubt directly. Abdullah, you were asking about the binary addition and subtraction, right? Okay, just give me a minute. I'll just open this. Yes, okay. I just opened my file. Number system you want. And don't worry, Francis, if we still have lab sessions. Okay, so if you have any doubt, you can ask in that class also. Okay, we still have lab sessions. Abdullahi wanted to ask that doubt, but his network is so poor. Now you tell me, what do you want to clarify? So I'll open that topic only. Yes, tell me, Francis.
Yes, I wanted you to elaborate more on the number system, the
I mean, how
subtraction and addition.
binary arithmetic you want to ask?
Yes, binary.
That's what that Abdullahi was asking. So this number conversion is clear, na? You just want this binary mathematics.
Yes.
This is how, like, 0 and 1 will be 1, and 1 and 0 will be 1. This is binary addition. How I will do? 0 and 1 is 1. Now 1 and 1, what is the rule for 1 and 1? 0 and carry 1. And see, there can be some, what do you say, typing errors also. Okay. So there should be 0, 1 and 1, 0 and carry 1 and then this. And this is, I have written some wrong number, I guess. 0, 1 and 1, 1. Okay. So I think this should be, I have written this wrong here. 0, 1. Yes. Now this 1, 1 is 0, carry 1, 1, 1 is again 0 and carry 1 and then this carry 1 will come down. So, no, but this is not again correct. This is 2 and for 1 this is 0, 1. Now, now this is 1, 1 and 0. I have typed some wrong here, but the main thing is like you have to follow these rules only. That's it. Like if two both are 0, result will be 0. If 1, 0 and 1, 1, no carry. 1 and 0, 1, no carry. And 1, 1 is 0 and 1 carry. If there are three inputs, then what will be the rule? All are 0, 0. If there is only 1, 1, 1, here also single 1, so result will be 1. And if there are two ones, then result will be 0 and carry 1, like we did here. Two double 1 means result 0 and carry 1. And again, single 1 means result is 1, no carry. Here again, there are two ones. So what will be the answer for two ones? Francis, if there are two ones,
It's 0.
yes, result will be 0 and carry will be 1. Here also two ones, result will be 0 and carry will be 1. What is the rule for three ones? Result is also 1 and carry is also 1. This rule you have to follow. And if I am saying that there can be some typing mistake, you can try practice from your own material also. Okay. See, I
Okay.
think this, if I type one, yeah, so this is 1, 1 is 0, here 1, carry 1, then this 1, 1 is 0, again carry 1 goes to the next column, then again 1, 1, it should be 0. So there is some typing errors, but you have to follow the rules, right, Francis? So there is some typing mistakes in this. And we see the binary subtraction. This one 101 plus 101. So let's try this. 101. So here 1 1 is 0, carry 1, then 1 0 0 will be 1, and here 1 1 is again 0, carry will go to the next column, and there is no next number, so here that carry will be brought down as it is. So this 101 plus 101 will give you 1010, right? Francis, still if you have any doubt, don't worry, you can ask me anytime.
Yeah, I think I've understood.
It just needs some practice. Just needs some practice. And there may be some typing mistake in my file, I'm telling you. Yes, Abdullahi, did you see how I solved this? Yes, Abdullahi, I'm asking you. Okay, now see the subtraction. For subtraction, what is the rule? Obviously, when 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0. But when you subtract 1 from the 0, then result will be 1 and borrow will be 1. So as I said, when we subtract, like if you have to divide, you have to subtract, if I say 13 minus 25, 13 minus 25. So how you will subtract? 13 minus 25. So how you will subtract 5 from 3? You will take borrow from the next column. Clear?
Yes.
Right. So the same way here also, you will take borrow. So now if 1 minus 1 is 0, 1 minus 0 is 1. 0 minus 1, it will take borrow. So when it will take borrow from here, it will become 10. 10 means 2. Here, this 10 means 2, because this is binary number system. In decimal number system, when we borrow 1, that adds 10, but here when we borrow 1, it means it will become 2. 2 minus 1 will be 1, and here this 1, from this 1 we have given this borrow to this column, so here what is left? 0. So 0 minus 1 is 1. Okay, next here, so this is how you will practice. So practice from your own material. So this was binary addition and subtraction. So still, if you have some doubt, you can ask me in the lab session also. Right, Abdullahi? Do some practice. And I was saying that there can be some typing mistakes in my files also. So don't go by that whatever some numerical is written in my file that is correct. No, there can be some typing error. So you do by the rule and practice from your own material. Yes, Francis, tell me.
Yeah, so we have been receiving assignments
Hmm.
on Ignore group.
Right.
So how are we going to submitting the assignments?
That must be mentioned there, that you have to solve it and then you have to make it one PDF and then you have to send that one PDF. I hope. Still, you go through the instruction, but as far as I know, You have to solve all these questions. That there may be some theory questions, there may be some question from Word, one question from Excel, one question from what do you say, PowerPoint. You have to solve it in that particular software on the system, that practical related questions, and then you have to convert it in one PDF, and then one PDF you have to send. Okay.
I
Do
submit to whom? Do I submit?
there, yes, that link must be given in on that LMS, na? That I email ID must be given over there.
No, our class coordinator is not like, I don't see his email.
Okay, I'll find out and let you know.
Yeah, for other courses they have class coordinators, but I don't see for the CIT
Okay,
class coordinator email.
I'll search for that email ID and I'll let you know.
Okay, please.
Okay, give me a
Yes.
day's time. By tomorrow, I'll let you know. And see you after
Okay.
15 minutes. Okay, for the lab
Okay.
session.
Okay, please.
Okay,
Thank you.
bye bye.
Bye.